Hi, welcome to this video. In today's video, I'm going to give a nice proof for the geometry series as a convergence series. So let's set this sum of a sub k as k goes from 0 to n, okay, with a sub k equal to c is multiplied by x to the k, okay, c as a constant. So non-zero terms with non-zero terms. So this sum of a sub k as k goes from 0 to n equal to the sum of c is multiplied by x to the k as k goes from 0 to n equal to, I'm going to distribute this one. I will have c is multiplied by x to the 0, which is 1, plus x squared plus x to the 3, and all the way down until you get the last term, x to the n. Okay, so what I'm going to do now, I'm going to multiply both sides by 1 minus x. 1 minus x is multiplied by this sum, c is multiplied by x to the k as k goes from 0 to n equal to c is multiplied by 1 minus x is multiplied by this sum, 1 plus x squared, and all the way down, and so on and so forth until you get the last term. So what I'm going to do now, I'm going to distribute this one. I'm going to factor out this one. So I will have c is multiplied, 1 is multiplied by this sum, is giving me 1 plus x squared plus x to the 3, and all the way down to the x, up to the x to the n. Okay, minus this x, I'm going to multiply this x with all these terms. Okay, I'm going to multiply x by all these terms, is giving me minus x. Okay, minus x squared minus x to the 3, and all the way down until you get, and minus x to the n minus x to the n plus 1. Okay, as you see here, the most of the terms will be cancelled out. So x will be cancelled out with this x squared will be cancelled out, x cubed will be cancelled out, and x to the n will be cancelled out. I will be left with this one, c is multiplied by 1 minus x to the n plus 1. Okay, so this one equal to 1 minus x is multiplied by this sum, c is multiplied by x to the k as k goes from 0 to n. Okay, what I'm going to do now, I'm going to divide both sides by 1 minus x. This one equivalent, this sum, which is c, is multiplied by x to the k as k goes from 0 to n equal to this constant c is multiplied by 1 minus x to the n plus 1 over 1 minus x. I'm going to replace cx to the k with a sub k. Okay, so this one equivalent, the sum of a sub k as k goes from 0 to n equal to c is multiplied by 1 minus x to the n plus 1 over 1 minus x. So now I have this sum, the sum of a sub k as k goes from 0 to n equal to c is multiplied by 1 minus x to the n plus 1 over 1 minus x. Now, as a convergence series, we set x is strictly inferior than 1. Okay, so with x, with absolute value x is strictly inferior than 1, this implies, if I'm applying the limit on both sides, so we'll have the limit of this sum, okay, as a sub k as k the sum of a sub k as k goes from 0 to n, as n goes to infinity. If I'm applying the limit on x to the n plus 1, this one is tending to the 0, okay? So we will have c over 1 minus x because the limit of x to the n plus 1 equal to 0 as n goes to infinity. Thus, this series is a convergent to the c over 1 minus x, okay? Let's take the example to support this proof. The example, set c equal to 1 as a special case and x equal to 1 over 2. This one implies I have the sum of e sub n as n goes from 0 to infinity equal to 1 over 1 minus 1 over 2, which is equal to 2, okay? So now this series a sub n as n goes from 0 to infinity converges. Now I have done with this problem. Just consider the subscribe. I will see you in next video. Bye.